My today's topic, because I have limited time of 45 minutes, which has been allocated by the persons who have arranged this exhibition. In the short, I will covering the water treatment, filtration, membrane technology, ion exchange, and wastewater. In 45 minutes, I can just give you the overview of these technologies or the water situation. Later, we can have a webinars to understand each and every a part of it. Next. Water, water is H2O. It has two hydrogen molecules and one oxygen molecule. Its atomic weight, molecular weight is around 18 grams per mole, and the angle between the hydrogen and the oxygen ion is 104.45 degree. Next, the sources of water. We have the sources of water, surface water mainly, and the groundwater. Groundwater comes from the streams, lakes, ponds, rivers, embedded reservoirs, and store rainwater. Sometimes we, in desert areas, we have the catchment ponds where we store the rainwater. Next. Oh, why to treat the water? Basically, the treatment objective are different. First, the objective we consider is the drinking water. How to provide a safe drinking water to the human being and the society, so that, and the irrigation purpose. And this is next. Then, yeah, मुझे दे दें आप. I think you are a bit slow. I can manage. And the second is the industrial water requirement. Just चलिए उसको छोड़ते हैं. And one we treat for the water for the human and agriculture purpose, and second purpose is for the industrial use. In the industrial use, we have a different requirement, like for the boiler, cooling tower, process water requirements, which creates the problem to the efficiencies of the various equipment. This is the global water availability. You can see, yeah, इसको close कर सकते हैं आप mobiles को, bells को please. We have the total global water availability 96.5 to 250 milligrams per liter. And if you see the other waters which we take from the tap having 450 or up to 1000 TDS, you cannot distinguish from the color of the water that how much TDS this water have. It means that those are dissolved. Those types of minerals, they are called the dissolved salts in the water. Yeah, dissolved solids, and the total suspended solids are those which we can see. If you see the river water, dam water, you see there is some sort of suspended contamination coming up, and these are normally visible with the naked eyes. And these again are of two types, which will not, I will try to go further. One is the non-settleable, other is the settleable, and in the dissolved solid, volatile, and fixed type both we have. We will have a little idea in the next slides. These are the total contamination which I have summarized for you to understand. And that on the top column, you see the substances, suspended impurities, colloidal impurities, dissolved impurities, cations, and anions. These are generally the water composition, which is foreseen in the various sources of water. And you can review that in the suspended impurities, you have the sand, clay, inorganic solids, and the organic impurities, top of soil, ground, or decomposing or organic matters. And then we have sometimes the gases, living organisms, algae, fish, and minute animals. In a colloidal impurities, we have silica, clay, iron. You can review this table, and I would like to focus on the last two slides, last two columns. Normally, this is the dissolved solids, and people we are using, there are more concern for our drinking water. Especially, we have to remove this contamination to make the water fit for the domestic use or make it mineral water or it's bottled water or for industrial use like textile processing, sugar, boiler, cooling towers. These are parameter cation anion. These cation anions are basically removed by either by the ion exchange process or the membrane technology. And the impurities, which are the colloidal and the suspended, uh, they are removed by the physical treatment. We are like a filtration in the sand filter, activated carbon multimedia. If we have arsenic or the fluoride, we can use the respective media for their extraction or absorption as well. And for the dissolved impurities, we have to go for the membrane technology, which is very popular nowadays. A company like Dow, Hydronautics, and other, they are manufacturing good quality membranes for various applications. And we will, in our next, my presentation, which is due on 2:30 p.m., 5th of November, I will try to cover the factors which are affecting the performance of RO plant and the membrane. And I will also try to cover a little bit how to design a perfect system which can meet your expectation. A proper design of pre-treatment is very much required for designing the RO and the UF system. And we will discuss in the later sessions. Now, effect of various impurities, just because this is a seminar or international conference in which the people from the various segments of the life they are participating. Some are from the industry, some are from the general public, and some students. They everybody want to learn okay, what is the root causes, and why we need to treat the water and the wastewater. And just I have summarized the for the information of those who are interested to learn why to treat the water. That I have given a slide in which I have explained, try to give you some idea about the effect of various impurities in the water. Suspended impurities, we have the bacteria, algae, protozoa, and clay silt. And you can see the bacteria causes the diseases, algae causes the color and turbidity, clay and silt causes the turbidity. And if we see the calcium, magnesium, they exist as a calcium carbonate, calcium bicarbonate, calcium sulfate, calcium chloride, and these are general. What the industrial causes, root causes, what are the problems in the industry, you will see. Likewise, the sodium, which is present in the water, it is available as a sodium bicarbonate, carbonate, sodium chloride, and the sodium chloride. Sodium chloride, and you can see the effects of this various ions present, your molecule present in the water. And these are the metals. Sometimes metals are also present: manganese, iron oxide, lead, and arsenic. These arsenic is a poisonous and carcinogenic as well. Lead also poisoning. This is also carcinogenic and create life-threatening sometimes. In Lahore, 5-10 years back, the industries had been discharging the untreated wastewater, and we observed that fluoride concentration in the wastewater at that area was very high, and the newly born babies and the kids below 5 years, they had a problem of bending their bones. And we need to address every problem. And one thing important here is to share with my audience and the participants that normally we ask our uh, experts or the contractor, EPC contractors or the water treatment equipment supplier, I need a 10 liter, 20 liter, 1000 liters per minute drinking water plant. And they don't provide any analysis, water analysis. Actually, sometimes you don't need the RO plants. Sometimes you need the ultrafiltration plant. Sometimes you need iron removal or arsenic removal or the selective iron removal. Please, it's my request to all that whenever you want to plan any water treatment or the wastewater treatment facilities, first get the all parameter tested so that you should know what is the problem and your consultant or the designer or the EPC contractor can offer you an appropriate solution. Otherwise, they cannot provide the universal coverage to the pre-treatment or the that all type of a option should be kept in the treating this water. Better to spend 5-10,000 rupees and uh, get the sample tested from a reliable lab existing in your areas, and it will give you the exact idea of what type of a treatment you require, and it will also secure your investment as well. No, this is the waterborne diseases, and we have the mainly the in water, the bacteria, protozoa, worms, virus, and fungus, and they create the typhoid, dysentery. You can see amoebic dysentery and malaria, yellow fever. These are the microbes which are causing the problem in the drinking water. In the 90s, World Bank carried a survey in Pakistan about to develop and to assess the need of the hospital in Pakistan. And that report is available on the net as well. They observed that in Pakistan, around 60% bed occupancy in the hospital is due to the waterborne diseases. Then they plan that and advise our government that we should focus on our water quality so that your hospital capacity can immediately be enhanced, and when your patient due to the waterborne diseases will not come to the hospital and they will be treated at home. You can have immediately 60% availability of the beds. That's why that clean drinking water for all this project was initiated in late 90s, and till to date we are unable to execute that project. We couldn't supply the clean drinking water to our society, which is the uh, basic challenge for the government, and we don't want to criticize the government on this project by request that they should feel the responsibility and that our people need the clean drinking water, at least apart from the other challenges. This is the basic challenge, and so that the newly born babies and our new future generation, they can avoid such problem or diseases and have a good health. When you will be having a good health, you can contribute the best to the society. Now we will talk some parameters apart from the TDS. We have the pH scale. You can see, just develop a slide for you to understand what is the pH of various commodities like fruits, vegetable, and the blood. You can see, and normally the pH of water is 7 is considered as the neutral, and the blood has the 8 pH. You would be surprised to see our stomach. Stomach acid has around 1 pH, and our blood has 8 pH. That is uh, you need to learn on it that our various organ of the body has a different pH, and that's the nature how we are operating. Our Allah Ta'ala has made our body that in a various organ has a different requirement of pH, and that automatically that is built up. Now we need to understand when we operating our system water treatment, and we'll do the sampling or we'll do the testing, and there is a direct link of pH versus temperature. You know, from this graph you can see pH increases as the temperature decreases because we have the bicarbonates in the water, and that is H positive and OH negative, hydroxyl and hydrogen ion. When bicarbonate decomposes, and that results in effect on the pH with the temperature. And there we have the relationship of conductivity, because the measurement of TDS, it is by the evaporation process and it takes some time. But in water treatment technology, the direct measure of the TDS, we can correlate almost. If you have the 10,000 conductivity, mean you have the 5,000 TDS. that just a thumb rule for you, and it may vary from a factor of zero point 0.5 to zero point 0.7. That depends upon the ionic composition of that sample. It is just for your reference that in water treatment we correlate the conductivity and TDS as well. And here you see, this is again, that was for the previous slide was for the high water conductivity. We had a millisiemens per centimeter, and this is for the lower water TDS. And you see the behavior is almost same. And if you see the left side conductivity table in a color table, you will see that 15 degree, 20 degree, 25 degree. Normally, we take the 25 degree as the standard temperature for the measurement of all um, laboratory testing. But one thing I assure you that if you take the sample of the water, especially for the RO product or the dimming water, its pH is very unstable. If you take it in the, if you measure online, the pH will be different. If you take it to the lab, the pH will be different because water absorbs the carbon dioxide from the air, and it's make the carbonic acid and which lead to the, lowering the pH, and this will be different. And it is better always to measure the online or the flowing water pH at duty point, and you can have a beaker and keep the water flowing in that beaker and put the electrode in that, and then you will be having a representative pH of your stream. Similarly, an oxygen is an important factor which is present in the water. Normally, in the fresh water, around 6 to 8 milligrams liter oxygen is present in the water, which is very much required for the aquatic life. In the fresh water, this is a graph for you better understanding at the various temperature. You see when the at low temperature, the oxygen concentration come to the zero, and you will see that we have for the seawater, we have around 11 milligrams per liter oxygen, and for the fresh water, we have around 40. But as the temperature increases, the oxygen concentration in the water, it decreases. You see, at the 50 degrees centigrade, we have around 5 or 0.5 or something like that for seawater, and for fresh water, it is 6 maximum. Hardness, a little bit hardness because another important factor for our industrial use, especially the hardness, or the domestic use, even we see that scale formation occurs in our taps and the lines in the home where we are using the water, and that is mainly because of the hardness. And similarly, when we go to the industry, we in a various process require specific water, especially when we go for the heat exchangers like cooling the boilers and the cooling towers. There we have the scale formation, and we need to keep the surface clean for the fish to have a good efficiency of the boilers and a good efficiency of the heat exchangers, so that we have where the scale deposits, there is no transfer of heat take place, or very poor transfer of heat take place. That's why we require to soften the water for our in Europe and America, and even in Pakistan to some extent. It has started the trend that we use the soft water for our residential purpose, and normally in industry for the boiler and cooling tower, low pressure boiler and cooling tower. We have the two type of hardness which are present in the water. One is the temporary hardness, and another is the permanent hardness. Temporary hardness is mainly due to the carbonates, and permanent hardness is due to the non-carbonate compounds. And major source of scale in water, boiler, cooling tower, you can see I have already explained you. And this is a table which I have shaped for your information generally how we categorize the water. Uh, Soft water, actually, different in different countries, we have a different measuring units for this hardness. And some, if you see on the top, there is ppm as calcium carbonate is a very popular unit in Pakistan and the US, and grain per gallon, German degree hardness, Clark hardness, French hardness. In these, we have the conversion factor. If you see 60 ppm as calcium carbonate, that will be equal to less than 3.5 grains per gallon, and German hardness likewise. And medium hardness, you can see 61 to 120 ppm is the medium hardness, and 121 to 180, that is hard water, and greater than 180, it's very hard water. That's the classification of water with regard to uh, uh, water hardness. A little bit on the filtration techniques. I think my time is over. I beg permission from my host that can I continue for 15 minutes more because I have a lot to cover.
जी जी मलिक साहब आप कर सकते हैं, कोई इशू नहीं है, आप करें।
Thank you.
स्पीकर भी ऑन टाइम है। दूसरा फिर आपने क्वेश्चन आंसर सेशन भी है, इसमें कुछ लोगों ने क्वेश्चन
Yeah, I will try to quickly cover it.
Now, sure. Carry on.
Thank you. I have already explained that we have two types of impurities in the water. One is the suspended and other is dissolved. Now, a method of treatment we will discuss. They are separate for the suspended impurities and the dissolved impurities, and it also depends what type of water you require for. If you require the drinking water, we'll be having different treatment scheme. If you have processed water for boiler, high pressure boilers, we require ultra pure water. If you require for the medical, pharmaceutical purpose, every process requires a different type of water, and your designer or the consultant or the contractor has to supply the equipment as per the need of your two requirements. One, what type of water you are having, and the second, what is your required quality for the process. That required quality is given to you by your machine supplier or the process developer. Like in a textile, you will have to see for the dyeing, finishing, bleaching, what type of a water is required. Normally, at the high pressure boilers having 80 bar pressure, they require the conductivity less than 0.01 microsiemens per centimeter. We have to achieve that targets by employing the equipment based on the type of available source. And for the physical impurity, what is the objective? Purpose of various treatment is to remove physical impurities, chemical impurities, bacteria, color, taste, odor, whatever is the present, we have to remove to meet for its utility, which we intend to. In these broadly classified treatment, we have for the physical treatment, we have the screening, plain sedimentation with coagulation, like Northeast key project at the Hub River. What we are having, we have a rainfall water, we are collecting in a dam, and then we are doing the coagulation, flocculation, and filtration process, plus the disinfection that is being done. And that all processes employ your screening, plain sedimentation with coagulation. And these are employed on the surface water for the removal of suspended solids. And this technique is very old, and now we are having alternative advanced technologies. We can also go with the ultrafiltration with techniques which require far low area and far low time for setting up the project, and its reliability is higher than this conventional sedimentation system, because you need to have the proper dosing, jar testing, control the parameters, sludge handling, lot of other things you have to manage and to control the process. And then in the ultrafiltration, even the microbes, you don't sometimes need to have the chlorination if your storage capacity is not much higher. Otherwise, you can have a drinking water without chlorination as well. when you do the chlorination of the water, then you have to do the dechlorination through activated carbon filters or sodium metabisulfide or calcium metabisulfide. This is a process which we need to understand. Now, the selective ion removal, we have the beam that reduces the iron and manganese compound present in the water, and we have the sand and gravel filter remove the floating particles suspended solid up to 40 micron. Then we anthracite activated carbon filter. This is their application normally which we have. I have mentioned in this presentation, and I will ask Kamran Saab that they can upload this video, or they can share the PDF file of this presentation to the participants so that they can have a thorough review of this presentation, and they will have a little idea about basics of water and wastewater treatment, and what are the issues and what are the challenges and how do we have to handle it. It will also be available on my YouTube channel, and on the end of the slide, I will give you the YouTube channel. You may join my YouTube channel to have the previous, you can view the previous my presentations or the sessions which I have conducted various on webinar, and I have also conducted some CPT courses which are available on my YouTube channel as well as on the PC website as well. PC stands for Pakistani Council. Yes, Kamran Sahab, you were trying to say something.
Basically, the other speakers are ready to join. So if you come up or to close ASAP, and also few questions are there, so you can reply on it.
Okay, just give me 2 minutes. I will close.
Sure.
This information about the sand filter, how to design the sand filter, and you will get the idea multi-layered there, how much velocity we have to cap and what size of a particle they remove. And this is a multimedia filter. You can see it have multiple medias that depend upon the application, that what we have to do with that. Now come to the ion exchange technology. Dow is the leading company in the ion exchange technology, and Dow now has been acquired by the DuPont. And initially, it was Roman Haas who developed the technology, and Roman Haas were acquired by the Dow, and Dow now has been acquired by the DuPont, and DuPont is now our channel partner, and we are having a technical collaboration on their products and the technology. They offer the good services and the support to their OEMs, and appreciate their support. And you can see the ion exchange system we use for the boiler, beverage, soft, and processed water requirements. And this is the ion exchange applications you can see. And in the strong, we have the different type of resin for different applications. You see the resin type I have mentioned. You can review it, and they are different for the different application, and I have given their application based on their type. And membrane technology. Membrane technology, I think Mr. Dimitri will also be giving covering this topic today or tomorrow. He has a slot there, and I hope that Mr. Dimitri can cover a better presentation on RO and UF than me. And I leave it to him that they should give you the more idea or more detail about their product and application. Just I will overview these technologies, reverse osmosis system. This is, and in membrane technology, we have the 4 type of a membrane: microfiltration, ultrafiltration, nanofiltration, and RO plant. And you see, this is basically the molecular seal, and you can see the what type of a pore size they have. They will not allow the particles bigger than this pore size to pass in the water. And these are the pore configuration, and based on their application, we select the membrane, what type of membrane is to be selected for the for microfiltration, ultrafiltration, nanofiltration, and RO. This is a table which shows the microfiltration. It passes the water, only rejects the bacteria and suspended solid. And ultrafiltration, you see, it rejects the virus and bacteria. All chemicals are passed through it. In RO, only the water positive. This is the filtration spectrum. You can understand the what type of molecular weight, various dyes, molecules of sugar, soluble salt, LGs. You can see these size of molecule. Accordingly, we select the membrane. Let's come to the wastewater. Wastewater, we have two type of a wastewater. One for the domestic sewage treatment, sewage, and the other is industrial wastewater causing this problem. And in the domestic, we have two type of a water. One is the gray water, while other is the black water. And this is in the wastewater treatment, we have the physical, chemical, biological, anaerobic, and aerobic treatment, sewage treatment, recycling of wastewater, zero liquid discharge. This is trending now for the water conservation. And these are the wastewater characterizations, physical, chemical, and biological. The physical parameter we have to remove by the physical treatment. Chemical parameters we have to use by the chemical treatment or by precipitation or employing the physical treatment, and the biological, they only do by the anaerobic or the aerobic processes. We have in the wastewater treatment the primary, secondary, and tertiary treatments. And you can see the general idea of the conventional or the activated sludge process, that is screening, equalization, clarifier, and then we have the aeration tank, secondary clarifier, and supernatant sound. And then we have another type in this activated sludge process, the sequence batch reactor, and that control various that's covered the small projects. It can mostly they are not preferred for the big industrial water uses, and we have a sequential batch reactor. These are also used for the medium industrial applications and the sewage treatment. And moving bed bioreactor, this is another type of a system which we have in the wastewater treatment. And this is membrane bioreactor and MBR. And this is wastewater recycling. And how we recycle the wastewater. This is the general concept. We have wastewater treatment plant, then we have the ultrafiltration, and then we have RO. And from RO, we have the two stream. One is goes to the process use, and the other goes to the reject. That is to be disposed of in an appropriate manner. If alternative scheme is that if you install the MBR based wastewater treatment plant, then you don't require the ultrafiltration system in this scheme. These are the liquid discharge standards, various standards, local NEQS, which are now split in every province has made their different standards now. Our standards are same, but Sindh now says that the SEQS, Sindh Environmental Quality Standard. Initially, they were the National Environmental Quality Standard, and now we have the textile people know they have the BSR standards now, which are globally being practiced, and it will be implemented within the next 5 years. And ZDHC, we have the standard which their buyers are